Bismillahirrahmanirrahim. Assalamu alaikum, students.
وعليكم السلام ورحمة الله.
So last time we were studying this chapter number 9. And in chapter number 9, last time we have studied about the collision. And in collision, we have discussed with the elastic collision in one dimension, and then elastic collision in two dimension. And then today I want to discuss with you the inelastic collision. So last time we have seen that if two bodies collide with each other, they are moving in the same straight line like this one. This is called one-dimensional collision. And the second case was if one body is here, the other body is colliding with this, touching like this one, then after collision, one body move in this direction and the other body move in this direction. Then we call it two-dimensional collision. This is elastic, but two-dimensional. And this is elastic and one-dimensional collision. So last time we have seen and checked all the equations of one-dimensional and two-dimensional collision. After this, the last article of this chapter is inelastic collision. So inelastic collision is what? Inelastic collision is this one, in which the momentum P is conserved or remain constant before and after collision, but kinetic energy is not conserved. Not conserved. So here we will discuss the case in which that both after collision, suppose this is one body and this is another body. After collision, when they collide with each other, after collision, this body will stuck with this one, will attach with this one, and then both bodies move with a common velocity. With a common velocity. VC mean here common velocity. So we want to see and check this type of collision. Okay. So inelastic collision mean that momentum is conserved. Only momentum is conserved. Okay. Not kinetic energy. So we are not discussing about the kinetic energy here. And second condition is this one. We will see that if one body and the other bodies will stick together, and now they are considering one system and they move together, and we will find the combined velocity of both masses m1 and m2. Suppose this is m1, its velocity is u1. This is m2, its velocity is u2. So before collision, its momentum is m1 u1 plus m2 u2. After collision, momentum is conserved here. Momentum is conserved, mean constant. So after collision, both bodies stick together, then their masses will be added and they are moving with the common velocity. So if you want to find the common velocity in case of inelastic collision, what you will do? You will find the collision momentum, total momentum before collision, and that is m1 u1 plus m2 u2 divided by m1 plus m2. So we will apply this formula to solve our problems for the combined velocity. So here remember that initial kinetic energy is greater than the kinetic energy final. Surely the initial will be more. and some energy is lost in the deformation, but in elastic collision, that lost retain, but here does not retain or regain. So this is all about inelastic collision. So you should remember this equation, and you can solve the problems. Okay, brother. So this is all about this chapter number 9, and this is our chapter number 9 theory, and this 9 theory is finished. Okay. So the final exam, maybe Dr. Michal has sent you about the syllabus or not? Yes. Any student?
What, doctor?
The syllabus for the final exam, the Dr. Michal send you or not?
No.
Okay, I
Yes, I think maybe he said till chapter 9.
Yes, until chapter 9. Yes, yes. That's I want to discuss. So your only you have a chapter number up to chapter number 9, from chapter number 1 to chapter number 9.
Right.
Still they have decided this one. I think it's no final. Okay. So you have to control all these chapters from chapter 1 to 9, and they remove this chapter, rotational dynamics or rotational motion. So rotational motion is also an important chapter in which we discuss the torque and the angular momentum. Here we use the linear momentum, but here we are using the angular momentum or cross P like this one. But anyhow, this chapter is not included in your syllabus. So up to chapter number 9, you have to control all these things. Okay. After this. So I'm starting this problems of this chapter number 9. And first I will solve problems, a little easy problems, and then we will go in the difficult side. So first is this one: if a body of mass 10 kg is moving with a velocity 5 meters per second towards right, it is moving towards, this is important, that's why I am explaining this one, towards right. So it's moving towards right, then the momentum will be mv, and this is equal to 5 into 10, and this is equal to 50 kg meter per second. So this 50 kg is plus because the velocity direction is in positive side, one thing. The second thing, if the body is moving in this way, and this is 20 kg and it's moving with 3 meters per second, then the momentum will be minus 60 kg meter per second because it is moving in the negative x-axis. Velocity is in the negative, it is the velocity. It is not a speed, it is a velocity. So remember this one, it's a velocity. Okay, after this, we have another example. Example is this one. If we have this 50 kg, this is a 50 kg block and 200 Newton force is applying on it. For time delta t is 5 seconds. This is the data which is given, and the initial speed is 10 meters per second. Now the question is, find the impulse. Impulse. So you know that impulse is equal to force average multiplied by delta t, like this one. So you can multiply this one. This is the average force, and this is 200 multiplied by 5 seconds, and this is your answer. Newton into second. Okay, one thing. The second question is find the change in momentum. Change in momentum. So you should know that change in momentum mean impulse. Same thing. So what will be the answer? 1000 Newton into second. Same answer. Okay. If you want to find the final momentum, so final momentum is what? So before final momentum, I'm writing here, find the final velocity. Final velocity. So final velocity is what? So delta P is equal to mvf minus mvi. This is the formula. We know change in momentum is equal to I, or this is equal to delta P. The same thing. So you can put here 1000 and this is equal to m is common and vf minus vi. So m is what? M is given 50 kg. So you can divide it by 50 and this is vf minus vi. So if I can solve this one, then it will be 20. So it means 20 is equal to vf minus vi. And vf minus vi is given, it is 10. So here I will put 10 and vf will be 20 plus 10 will be 30 meter per second. This is the final velocity. You can find like this one. Okay. After this, he is asking about the final momentum. So final momentum mean mvf. M is what? 50. Vf is what? 30. So you can solve it and its answer will be 1500 Newton into second, or you can write kg meter per second. So in this way, you can solve this problem. So here what I want to ask, to explain, simple formula is this one. So you should remember, okay, see here that delta P is equal to I. One formula is this one. The other formula is I is equal to mvf minus mvi. You can apply this formula. You can apply this formula that average force multiplied by delta T. You can apply this formula. You can apply the formula that I is equal to impulse is equal to area under f of t graph. So these are the formulas which are important for to solve the problems of the impulse. Okay, let's see another problem. So other problems are, let's see. We have this graph. Suppose this is the graph and this duration is delta t is equal to 8 millisecond. It is given. And this is here 300. And this is time axis in millisecond. This time axis is in millisecond. And this is the force in Newton. Okay. The question is find the impulse. Find the impulse. So to find the impulse, what you will do? 1/2 area of this triangle. 1/2 base into height. This is the formula. And 1/2 base is delta t. And delta t is from here to here. And this is 8 millisecond into 10 raised to minus 3 second. Height 300. This height is how much? 300. So you can solve this one. The answer is 1.2 kg meter per second or Newton second. One thing. The second thing, he is asking about find the average force. So average force you can find with the same formula. I is equal to F average multiplied by delta T. So F average will be what? I divided by delta T. So I is 1.2 divided by delta T, 8 into 10 raised to power minus 3. So the answer will be, this is average force, and average force is, if you solve this one, this will be 150 Newton. Similarly, if your scale is starting from 0, then surely the average, this is the maximum force. This force is maximum. So maximum force is 300 and this force is constant, then every force surely will be 150. Okay. After this, we have two graphs. One is this one. It has 5 millisecond and its value is here 300. This is time versus f of t graph. And then we have another graph. This is 10 millisecond and this value is 150. Now the question is, which graph has greater or lesser or what kind of impulse? So what you will do, you will find the area under the graph of this one, area under the graph of this one, and check the answer. So area under the graph of this one is what? 300 into 5 into 10 raised to power minus 3. You can calculate. This is 1.5 Newton second. Similarly, you can calculate here I is equal to 150 into 10 raised to power minus 3. So if you solve this one, its answer is also 1.5. So it means in both cases, the impulse is same. It is 1.5 and here is also 1.5. So what is the logic? The logic is this one. You have to find the area under the graph, area under the graph. Then you can find the impulse. Okay. One more thing that you should remember, that momentum is a vector quantity. It has the same direction as velocity. So if we have here the mass and momentum direction is this one, and also the same direction of the velocity. Direction of velocity and momentum will be same. So if you drop a perpendicular, then this will be your Py component and this will be your Px component. So P momentum is equal to Pxi plus Pyg. So remember here, momentum is a vector quantity. Okay. After this, I want to solve one more problem and let's see this problem. The problem is here, this diagram is given and the duration is 1/2 second and this is 2 Newton. Here mass is given 2 kg and V1 velocity at this point is given 1 meter per second is given. Now the question is, a 2 kg object is moving to the right, with a speed of 1 meter per second. When it experiences the force as shown in the diagram, force is here and time is here. What is the object speed and direction after the force ends? So surely the force ends here. We will find the direction and the speed. Okay. So to find this one, what you will do? First, you will find the impulse. We know the impulse is the area under the graph. So 1/2 base is what? So this is not 1/2. This is rectangle. So you can multiply this one because this answer here is 2. So 2 multiplied by this 1/2, and this is equal to 1 Newton into second. This is the impulse from this graph, because area is what? Length into breadth. Area is length into breadth, not 1/2. Okay, so this is I. So I is equal to delta P. Delta P is equal to mv2 minus v1. V1 we have here. So we want to find v2 minus v1 first, and this is equal to I over m. I is what? 1 and m is what? 2. So v2 minus v1. v1 is what? 1. 1/2. You can solve it. V2 is equal to 1/2 plus 1. So the answer will be 3/2 meter per second, or 1.5 meter per second. So in this way, you can solve this problem. Similarly, if this graph is not up, it is in like this in the downward position. So you will just multiply this one with the negative sign and then solve it. This is the same thing. Okay. After this, okay, so the last time I have discussed with you the momentum, change in momentum. So delta P is equal to change in momentum. Change in momentum. So momentum change mean mvf minus mvi. This is a formula. So last time I have explained you that if you have a wall, the ball is moving in this way and then come back. This side is positive, this side it is negative. So what you will do? So here the mass m, here the mass m. So you will apply the formula final momentum. Final momentum is this one. So it will be minus mv minus mv. This is mv. In this direction is mv. In this direction will be minus mv. So final is minus mv minus this one, and it will be 2mv. But if the ball is striking in this direction and m and v and come back in this way, this is minus mv, this is plus mv. So the change in momentum is final is mv minus. Initial is minus mv. So the total will be 2mv. So just the difference is what this negative, other is nothing. So you should control these things and carefully, otherwise difficult for you to solve this. Okay. After this, now I'm sharing you the problem of this. So see this problem. In this problem, you can see we make it a little smaller and in the middle. Okay. Let's see it's writing or not. Okay. So this is the problem. In this problem, a 150-gram baseball is shown with a speed of this, and it is hit straight backward the pitcher at a speed of 40 meters per second. The impulsive force of the bat on the ball has the shape as shown in the figure. So this graph is given. What is the maximum force that the bat exerts on the ball? What is the average force? So we have to find this one. Okay. First, what you will do? Its mass is given. 150 gram, and you can convert it into kilogram, and this is equal to 0.15 kg. One thing. Okay, the initial speed is 20 meter per second. It is given. Okay. After it is striking, then the final speed is 40 meter per second. This is also given. We need the F maximum. So to find the F maximum, what we have to do? But first, from this graph, we can find the impulse. Okay, let's see the impulse. So impulse is equal to delta P before this graph. And delta P is what? MVF minus MVI. And this is equal to MVF. So this is M is common, VF minus VI. And this is equal to 0.15. VF is 40 minus. This we will take minus. Why minus? Because if this is a bat, suppose the ball is striking in this way, it is a negative. Either the ball is striking this way or this way. The answer will remain just minus plus, but we want to make this answer plus. So minus of minus 20, and this is equal to 0.15, and this is 60. So when you multiply this one, your answer will be 9 Newton into second. This is our I value from this data. Now find the area. Area is what? 1/2 into base into height, because this is triangle. So our area is what? Area is showing the impulse, and this is 9. And 1/2 into base. Base means the time. The time is 0.6 millisecond. So you will put here 0.6 into 10 raised to power minus 3 into height. Average force maximum. This we need. Now you can solve it. 9 multiplied by 2 divided by 0.6 into 10 raised to power minus 3. So when you solve it, you will get the answer of F of max is around 30,000 Newton. Okay. Since the force is constant, then the average force will be what? Average force will be 15,000. Otherwise, you can find the average force with the formula. Check with this formula, I over delta T. So I value you put and delta T you put and solve it, and you will get the same answer here. So in this way, you can solve this problem. Okay. Okay, these are the simple problem which I have solved it. So next time I will solve more little tedious problems. Okay. And we will see and check this one in the next time. Okay, thank you. See you in the next lecture. Salam.